Hello, and welcome to this developer skill sprint on encrypting, app tethering, send, receive data. My name is Al Manarino, and I'm one of the Embarcadero software consultants. This skill sprint will cover how to use the new app tethering encryption hooks in RAD Studio to encrypt the data or stream before sending the data or stream to other app tethered connected devices, and how to use the encryption hooks to decrypt the data or stream after receiving the information. Now, the purpose of these developer skill sprints are to give you about a 20-minute session that focuses on a new skill that you can use immediately, and you'll get answers to your questions in a live questions and answer session at the end of the skill sprint. And this blog notes link you see at the bottom of the slide will give you the replay of the session, including links for sample projects used in this skill sprint. This skill sprint on encrypting, app tethering, send, receive data, and streams works with RAD Studio 10 Seattle, both with Object Pascal and C++ in both VCL and FireMonkey apps. This skill sprint will use Object Pascal examples, and in 2 days, on Thursday, January 21st, I'll present the C++ developer skill sprint on the same topic and use C++ examples. So since the app tethering encryption hooks work with both FireMonkey multi-device apps and VCL Windows apps, you can use them on Windows, Mac OS X, Android, and iOS apps. For this skill sprint, I'll quickly define what is app tethering and what can you do with it. We'll look at these 4 new event handlers to use as app tethering encryption hook events to allow you to encrypt the data or stream before sending the information to other app tethered applications using the on before send events. And then we'll use the on after receive events to decrypt the data or streams after it's received by the tethered apps. And we'll look at some example apps on how to use these events to encrypt and decrypt the data and the streams, and then we'll have time at the end for any live questions and answers. RAD Studio includes a feature called App Tethering, which is designed for mobile and the Internet of Things. App Tethering enables discovery and interaction with applications running on iOS, Android, Windows, or Mac OS X, including the ability to gather data or trigger actions on those remote applications. So for example, you could scan barcodes on a smartphone and have the data sent to a Windows application. The connections using app tethering can be made over Bluetooth or using TCP/IP. App tethering was first introduced in RAD Studio XE6 as a way to extend your VCL and FireMonkey apps to other companion applications. And the companion applications can be Windows, Mac OS X, and or FireMonkey multi-device apps. With app tethering, you can properly, safely, and securely exchange streams and data messages between apps, and you can execute remote actions like pressing a button remotely or moving a trackbar remotely. With app tethering, you can breathe new life into your existing Windows apps by extending Windows VCL and FireMonkey apps, connecting devices, sensors, data, and services to build connected apps to add to a distributed Internet of Things solution. So with app tethering, you can build connected apps. The app tethering technology lets us easily distribute an existing app user experience across devices and gadgets. So this is especially powerful for extending the utility of existing VCL desktop and mobile apps to integrate with the Internet of Things. And you can use either network Wi-Fi or Bluetooth Classic with app tethering. So today, as we see, we are surrounded by all these types of gadgets and wearables. So there are all kinds of Internet of Things devices that we can now connect to using RAD Studio 10 Seattle. With app tethering, you can breathe new life into your existing Windows apps by extending Windows VCL and FireMonkey apps, connecting to these devices, sensors, data, and services. Here we see 2 examples of using app tethering. This app on the left shows sending data between app tethered connected apps, And this app in the middle shows sending streams, images, between connected apps using AppTethering. So with AppTethering, we can share or send data or streams between two or more app-tethered connected apps. And for security, we need to encrypt the data and streams before sending to any connected app. And then we need to decrypt the data and streams when it's received by any of the connected apps. RAD Studio XE8 introduced these 4 new intercept event handlers for the Tethering app profile component to intercept the data or stream, allowing you to add custom encryptions to the data or stream before sending to app-tethered connected apps, and then use the intercept event handlers to decrypt the data or stream. The 4 new event handlers are on before send data, and on after receive data, on before send stream, and on after receive stream. Let's now go into RAD Studio 10 Seattle and look at some example apps on how to use these intercept event handlers to encrypt and decrypt data and streams in AppTethering applications. So here I'm using Delphi 10 Seattle subscription update 1. I have AppTethering apps that want to send data between 2 or more app-tethered connected apps. And for security, we need to encrypt the data before sending to any connected app, and then we need to decrypt the data when it's received by any of the connected apps. To the app, I added Memo 1 box and Memo 2 box to log messages to show how we are doing the encryption and the decryption. And the apps have a checkbox to tell the app if it needs to encrypt or decrypt the data. The AppTethering app profile component has these 4 new intercept event handlers to intercept the data or intercept the stream, allowing you to add custom encryptions to the data or stream before sending to app-tethered connected apps, and then use the on after receive data event or the on after receive stream event to decrypt the data or the stream after receiving the data or the stream. These apps will be sharing data between 2 or more app-tethered connected apps. And to create the data resource, we use the Tethering app profile property called resources. And here is where we can create our data resources. So for these apps, we created 2 resources. One resource called resource 1, which is a resource type of data, and a second resource called resource 2, which is also a resource type of data. The other resource type could be stream, but for these apps, we are only going to be sharing data. We enter the data we want to share in our edit box, and then when we click on our resource 1 button, we send the resource data from the edit box to the connected tethered apps by calling the Tethering app profiles send string method. But before the string data is sent, the Tethering app profiles intercept event handler on before send data fires, and that's where we can encrypt the data. So now let's look at the on before send data event. So looking at the Tethering app profiles event called on before send data, we see that it's a function for post-processing of the data that occurs before the application profile sends data to the remote application profile. So here is where we can process the A data buffer and encrypt the data before sending it to the remote application profile. Looking at the on before send data event, we see that it's a function, so you need to return the data you want. The constant A data buffer is of type tarray system.byte, and it's the incoming received data to the function. So in this on before send data event, here is where I'm taking the incoming data string and encrypting it using the exclusive OR cipher with a key of $55. So here I'm using a loop to go through the T array of system byte to encrypt the data with exclusive OR to every character using the key $55. It's important to say that any type of encryption algorithm can be used here. And for this example, I'm using the exclusive OR cipher. In cryptology, the exclusive OR cipher is a type of additive cipher. It's an encryption algorithm that operates according to the principles that a string of text can be encrypted by applying the bitwise exclusive OR operator to every character using a given key. And then to decrypt the output, all you need to do is reapply the exclusive OR function with the same key and it will remove the cipher. So here we are encrypting the data with this exclusive OR cipher to every character using a key $55. Now, exclusive OR is not the most secure encryption, but I'm just using it here as an example. Now that we have the data encrypted to the other app-tethered connected remote apps, we need to use the inverse function of this onBeforeSendData event, which is the onAfterReceiveData event, to decrypt the data. So let's look at that now. So next, in the other app-tethered connected apps, we need to use the onAfterReceiveData event to decrypt the encrypted data. So here we have the function for onAfterReceiveData, and we see that it's very similar to the function BeforeSendData. So here the A data buffer is the receive data from the remote application profile that encrypted the data. So here we can process the A data buffer and decrypt the data. Here in the onAfterReceiveData event is where we need to decrypt the string data and return the plain data result to the tethered apps. So because these are functions, it's important that you must always return the result for the functions. Similar to how we used exclusive OR cipher to encrypt the data, we use the same exclusive OR cipher to decrypt the data using the same $55 key. Using a loop, we go through the T array of system byte to decrypt the data with the exclusive OR cipher to every character using the key $55. Using these techniques with AppTethering, you can now add your own custom encryptions to the data or stream before sending to app-tethered connected apps, allowing safe and secure exchange of streams and data messages between apps. For additional techniques for the encryption and decryption of data and streams, you can use TurboPower's Lockbox. You install Lockbox using the Get It package manager from the IDE. TurboPower Lockbox is a free and open source Delphi and C++ builder cryptographic library providing efficient private key encryption, public key encryption, and hashing functions. It provides support for AES, strong encryption, DES, weak encryption, 3DES, blowfish, twofish, SHA, MD5, a variety of chaining modes, RSA, digital signature, and verification forms of encryption. Let's now run these apps and see what they do. I'll start the two AppTethering apps. One's called Cipher Server, and the other one's called Cipher Client. Click on the Auto Connect button of the Cipher Server app. This calls the Tethering Manager's Auto Connect method to start the automatic connection to remote managers on each registered adapter. and at the end of the search, the Tethering Manager's on end auto connect event fires, and we see that this app is app tethered connected to the other app tethered app, and we display the other app's Tethering Manager's unique manager's identifier. For both apps, I'll check the checkbox for encryption to tell the apps that we want to encrypt and decrypt the data strings being passed between the two apps. The edit box has the string data we want to send, and clicking the Resource 1 button sends the resource data from the edit box to the connected tethered apps by calling the Tethering app profiles send string method. But before the string data is sent, the Tethering app profiles intercept event handler on before send data fires, and the string gets encrypted using the exclusive OR cipher method with a $55 key. On the connected app tethered apps, the Tethering app profiles on resource update and on resource received events fire since we received a new or updated data source. But before the string data is received by the connected tethered apps, the Tethering app profiles intercept event handler on after received data fires to decrypt the data using the same exclusive OR cipher with the same $55 key, and we can see the plain text data. And this process works the same if I send data from this cipher client app to the cipher server app. So here I'm going to send hello from client 1 data, clicking Resource 2 button, and it works exactly the same way. The string data is first encrypted before being sent, and then the connected app tethering apps receive the data, and the encrypted data is first decrypted, and then we can see the plain text data. So all of this works great. This ends what I had time to cover on this skill sprint on encrypting app tethering send receive data. For additional resources on app tethering, see this DocWiki link on using app tethering. For app tethering encryption hooks, see this community.embarcadero.com blog post. For additional app tethering examples, look at the samples provided in 10 Seattle. The BD shopping list app shows app tethering sharing data resources between other paired profiles. The desktop cast app shows app tethering sending streams of screenshots and actions to other paired profiles. The media player app shows app tethering executing remote actions between other paired profiles, and the photo wall app shows app tethering sending streams between other paired profiles. And the lockbox homepage gives examples on how to use lockbox encryptions. For the next time, if you're using C++ and C++ Builder, in 2 days on Thursday, the 21st of January, I'll be doing the same app tethering encryption skill sprint, but using C++ Builder and C++ examples. And next week's developer skill sprint on Tuesday, the 26th of January, will cover practical data compression and decompression using Object Pascal, and doing the same on Thursday, the 28th of January, using C++. And you can see the full skill sprint schedule and replays at embt.co/sprints15. Let me quickly turn this session over to Jim McKeith from Developer Relations to let you know what are the current RAD Studio, Delphi, and C++ Builder special offers for this first quarter of 2016, and then I'll come back for any live questions that you might have.
Give me a brief moment to tell you about this limited time special offer. All 10 Seattle registered users get the bonus pack, which includes the new Object Pascal Handbook by Marco Cantu. This essential language reference is a modern language guide that includes new features of the language and the core runtime library, a must-have for any Delphi developer. Also get the Binder Converter Basic. It handles the heavy lifting when converting existing VCL applications into FireMonkey applications, so you can start taking advantage of multi-device development right away. And the Premium Style Pack includes premium styles for VCL and FireMonkey to make your application look great on every platform. For more information on these special offers, or to find out what the current offers are, please visit www.embarcadero.com/radoffer.
Thank you, Jim, for letting us know all those great limited time special offers. This ends this developer skill sprint on AppTethering encryptions. You saw how you can use the new AppTethering encryption hook events to allow you to encrypt data or streams before sending the information to other app-tethered connected apps, and also how to decrypt the data using the event handlers to get the plain text data. So thank you all for attending. Now let's open up this session for live questions and answers.
Okay, great. Thank you, Al, for this informative session. So we have a few questions queued up here. I'll go ahead and go through the questions, and you can answer them for us. So Andrew commented that you had the diagram up that had the ATs on the different objects, and he was curious if that was the Hayes command set or if that was something other reference for AT.
Yeah, that diagram with the AT, so AT just was a short word for app tethering, meaning any of those devices can be app tethered to other devices.
Okay.
Not to be confused with the Hayes commands.
Okay. Excellent. If there's any other questions, go ahead and put them in the question panel here, and we'll get them answered for you. Peter says he's using 4G to communicate with his server, and wants to know if he can tether via 4G internet. So if one of the devices is over a 4G connection, if he can connect to it through that.
Yeah, I don't see any reason. So you have for the adapters, it's either network Wi-Fi or Bluetooth Classic. So I don't see any reason why 4G would not work over Wi-Fi.
So since it's over internet, they'd have to use the specific IP address, correct? They couldn't do discovery. Is that right?
That's correct. You can also, yes, there's extra parameters in the auto connect or discover managers to hard code the IP address or a specific set of IP addresses that you want to connect to.
Okay. Ian's saying he loves the T-thread synchronize. Great new feature. He said he believes it was added in XC8. I can't remember exactly when that was added, but yeah, that's a great. I love being able.
Correct. Yeah. So that allows you to still have control over the form while processing is going on.
What is it? Synchronize, and the other one is queue, isn't it? Right, where you can queue the updates.
Adding null as that first parameter allows you to still interact with the user interface while that processing was going on.
Frank is saying that the UDP call triggers the firewall. Some firewalls.
That's right.
Yep.
How the app tethering works, it works on UDP broadcast to find other tethered managers, and there's specific ports that need to be opened for us to communicate through. I'm thinking they were 2020 to 2040. I think those are the ports that need to be open for this auto connect or discover managers to UDP broadcast.
Yep. Yeah, firewalls. Generally, the idea is that so firewalls can cause trouble between communication between devices. Guy pointed out that the blog notes page doesn't have any content on it yet. Is that something you're going to be adding shortly?
That's correct. So yeah, all the samples I've used here. So I'll include the sample I showed in this skill sprint on with sharing data back and forth, and I also have an example using encrypting streams. So I use the Desktop Cast app that sends streams, images between connected tethered apps, and I use lockboxes, encrypt, ANSI string to show you how you can use the on before send stream and on after receive stream.
Oh, excellent.
So yes, I'll update this blog notes link with additional samples for both data and streams.
Okay, great. We can look forward to seeing that. I'm excited to see the encryption using lockbox example. So, like you said, pointed out, the excuse me, the XOR is not really a secure encryption, but it's a lot easier to see in the examples, whereas lockboxes provide secure encryption options, but requires a little more setup and such.
Correct. The process is quite simple. So, just using those two events, whether you're using data or stream, just encrypt before you send, and then decrypt once it's received by the other app-tethered apps. And then you're allowed to add your own encryption or any other type of custom encryption you want. So these hooks make it quite easy to encrypt the data and then decrypt the data on the other side. This was a feature that was asked every time we did an app tethering type of session or webinar. That was a common question that came up. Wouldn't it be nice if we can encrypt the data and decrypt the data? So the good R&D folks at Embarcadero added these 4 event handler hooks for us to make it easy for us to add these custom encryptions to the data or to the streams before sending to other app-tethered apps.
Very nice, yes. The idea is generally that you're going to be on your local network and sure to be secure, but sometimes, yeah, you do want to have extra security. Can you send both a stream and data at the same time? i.e., example, a picture and a name for a picture.
Yes, and that's probably another great example I'll post on the blog notes page.
Excellent. Yes, app tethering is a fantastic feature. As actually a couple times I've been working on something and I was like, oh, I need to have this talk to this. And it's like, oh, app tethering, and just those few components, set a couple properties, everything just connects and it works great. I love the fact, and as you showed out, that you can have, you can establish the connection one direction and then send the data back the other direction. So it's unidirectional, which makes it great.
Really real-world examples of how folks have implemented app tethering. I'll add those links to those examples in the blog notes link also, to give you some ideas of what people have done using app tethering.
Very cool. Okay. Well, I think we've gotten through all the questions here, Al. Thank you so much for putting together this session for us. It was very informative. There's a question here about using app tethering over the internet. I know you usually talk about it on a local subnet, but can you use it over the internet as well?
Yeah. So Walter asked the question, is it possible to use app tethering over the internet? And the answer is yes. You can use app tethering over the internet through an IP network, such as a local area network or the internet. When you connect to other app tethered apps, the tethering manager either has an auto connect method or a discover managers method. So if you want to connect over the internet, you don't have that discovery option, but you can specify a specific IP address or a subnet of IP addresses to connect to. So we added that new functionality to allow you to do app tethering connection to a specific IP address or to a set of IP addresses for a specific subnet. So back to that answer. So the answer is yes. So yes, you can. And a common question I ask is, how does this app tethering discovery process work? Well, we use UDP over a local subnet using ports 2020 through 2040 for the UDP broadcast to find other apps that you can connect to. And you can also use specific TCP/IP addresses anywhere you want.
So now in your example, you showed that both sides had the same XOR encryption going on. Is that always required? Do you have to have the same encryption on both sides if you're going to use encryption?
Yeah, so for the sample I used, for that example, I used the exclusive OR cipher. So for that example, to encrypt it, you use the exclusive OR cipher, passing it a key, and to decrypt it, because I'm using exclusive OR cipher, I use the same exclusive OR cipher with the same key to decrypt it. So that's how exclusive OR cipher works.
So there's a question here if the lockbox cipher is reliable to use with sensitive materials.
So if you look at lockbox, it does have AES strong encryption. So using that with sensitive data will apply strong encryption, 256-bit strong encryption. So if you want to keep that secure data securely encrypted with strong encryption, Lockbox's AES encryption should work fine.
Yeah, one thing about encryption is important that you understand some of the principles of cryptography in order to make sure you're actually effectively. Because even if you're using AES, if you send your password in plain text, then it doesn't matter what you're using at that point. So make sure you understand the way cryptography works, because having good algorithms doesn't help anything if you do it incorrectly. So there's a question here. I have an Android app that gets data from a server using DataSnap, then I have to treat and send this data to 15 client Android tablets. When using TCP protocols, no problem. But using Bluetooth sometimes, just some of the 15 tablets are discovered and receive the data. Then I restart the app and data is sent to more tablets until the 15 tablets receive the data. Any tips or tricks around that? It works fine over TCP, but not as well for Bluetooth.
David, I hear you could set for Bluetooth, you could set a longer discovery time. That way it'll find as many devices as it can. It could be that the discovery time is only finding X number in that whatever that time is, if you set it for a second and a half, or maybe some of those tablets are not close at hand as far as Bluetooth. But I would play around with the discovery time.
Yeah, there definitely are fundamental differences in the way Bluetooth works over TCP/IP. If it's not currently discoverable on Bluetooth, or if the Bluetooth antenna is asleep or something like that, the net would certainly prevent it from finding it. So it may be that if you want to use Bluetooth, that you have to just have a routine that just keeps running and saying, hey, let's try discovering again, and keep doing that until it knows that all 15 have received it. So you might have some sort of handshake in there to verify that they've received it.
The bandwidth issue with Bluetooth differs than what you get over network Wi-Fi. So it looks like the answers given are probably the situation you're coming against.
So there's another question here. What if I create a discovery server in the cloud where all apps connect? Is it possible to make discovery available over the internet?
Something I have not tried, but
I was thinking, the UDP discovery is never going to work over the internet because the firewalls won't allow UDP packets to go. But if you have them all, everything connects to a known IP address to a server in the cloud, then that server can then act as a broker and broker connections between other clients. So everybody can connect there and find out the IP addresses of other clients and then connect to them that way. And that's the way some of the older peer-to-peer networks work, is that you have a single hub that everybody registers your IP address with, and then everybody else connects to that server, finds all the other nodes in the network, and then connects to those directly. You're kind of rearranging the way AppTethering works, but in theory, it probably could work. You're still going to have to deal with firewall issues. For example, if you're connecting off a NAT network through a router over a firewall to that central server and give them your IP address. That IP address you have is either A, going to be your local IP address, like a 192.168.0 something or other, or it's going to be the IP address of your gateway. And unless you have NAT set up correctly or your local machine is set up as a DMZ, then someone coming back and hitting that gateway is not going to get to your local machine again. So you would need to then reverse the connection and make sure that you have somebody that you can connect to. So, you know, something like this is possible, but you're looking at a whole set of complications just with the idea of communicating across networks that way.
Yeah, app tethering discovery is Bluetooth over those ports using UDP. So anything else you might want to do to set up your own world and then ultimately then connect an IP address directly, that's what app tethering provides for that additional hook for connecting through a specific IP address. So, but that's not, there's nothing built in to go out and search the internet or broadcast to the internet looking for app tethering apps out there in the wild, or even across multiple subnets inside of your own organization. The reason that R&D added is, and Al may have mentioned this, we added the specific connection to a specific IP address because we had a customer who had some apps on different subnets inside of a larger building or campus or whatever, and they wanted to connect them up. So we did I think Al worked with R&D on a workaround temporarily, and then we added that capability into a subsequent release of app tethering. So there's no discovery built in for app tethering to the internet, unless you create your own virtual tunnel, virtual private network across a whole bunch of things so that all these different computers, who knows where, look like they're on the same subnet. If you can do that technically through different technologies that we don't provide, then I guess you could do UDP discovery for those things that are on some kind of virtual private network. So have it.
Yeah, there's always lots of options, but you just got to make sure you understand what you're doing.
And just a reminder, all of app tethering can be used in your existing VCL apps. It can also be used in FireMonkey apps. It can even be used in other types of apps as long as you can use the non-visual controls for the app tethering components.
Yeah, that's one thing that's beautiful about app tethering is it lets you connect all your apps together across all the platforms. Fantastic. Okay, I think we're done then. Thank you so much for joining us, and we'll talk to you later.
Thanks everyone for attending, and have a great day.